Simplifying square roots is a pretty simple concept as soon as you get the hang of it. So you just need to do a couple of these. Couples will always go out and become one pair, and singles will stay in. So in math class, they are old school. You have to have a date in order to go out. If you don't have a date, you have to stay underneath your square root. So what you're doing is you're breaking these down into factor trees. So for 108, I know that 2 and 54 will go into that. Then I know that 54 breaks down into 9 and 6. 9 breaks down to 3 and 3. 6 breaks down into 2 and 3. So as soon as you break off from something, you can cross it out. So I broke off of the 9, I broke off of the 6, I broke off of the 54, and the 108. So what we're working with is all the numbers that are left. So I'm looking for pairs, and they don't have to come off the same tree to be a pair. So here's a pair, and here's a pair. So they're going to go out together. So the 2s are going to go out as the 2s, and the 3s are going to go out as the 3s. Then this 3 is single, so it has to stay inside. So what your answer is going to be is 6 square root 3. Okay, so same thing here. Making a factor tree of 200. So 2 and 100, 10 and 10. I could keep branching my 10 and 10 off, but I know that that's a couple. So I'm going to take them as a couple, and they're going to go out. And then my 2 is single, and I branched off the 100, and I branched off the 200, so that's all that I have left for this. So if you would have broken this down even more into 5 and 2 and 5 and 2, you would have gotten a couple of 5s and a couple of 2s, so you'd have 5 times 2 root 2, which is still 10 root 2. So it doesn't matter if you want to do it the long way or not. But as soon as you see a pair, you don't have to go any further than that. 16, you could break down, but we should know just off the top of our heads that the square root of 16 is 4, and that's your answer. Square root of 50, 25 times 2, which is 5 and 5. So we branched off, so we have a couple of 5s, they're going to go out. I have a single 2, it's going to stay in, and that's our answer. Square root of 12, 4 and 3, 2 and 2. So there's a couple. This guy's single, so 2 root 3, not 2 root 2. 2 root 3 is your answer. When I'm doing 392, I know that that's 2 and 196, 2 and 98, 2 and 49, and that is 7 and 7. Okay, so when you have long ones like this, it might be better just to cross off what you've branched off of. So we've branched here, branched. So that's what's left. So I have a couple of 2s. They're going to go outside. I have a couple of 7s. They're going to go outside. And I have a single 2. It's going to stay inside. So my answer is 14 root 2. Okay, I'm going to skip 7 and 8 because they're just the same type of thing. Let's look at 9 and 10. So the only difference is that this is already waiting outside. So you're still going to break down the 48 into 12 and 4, 4 and 3. So you could keep breaking this down if you wanted to. I could go 2 and 2, 2 and 2. If you really understand what you're doing, you realize that you could have just stopped with the 4s because you had a pair of 4s. But I'm going to get rid of the stuff I branched off of, which is here. So outside I have that negative 3 that's already sitting there. Then I have a couple of 2s, another couple of 2s, and a single 3. So now I'm just multiplying those together, and this is going to give me negative 6 times 2, so that's negative 12 square root 3. Okay, same thing on this one. Break down 252 into 2, 2 and 126, which is 2 and 63, which is 9 and 7, which is 3 and 3. So then I can cross off what I've branched off of, the 9, 63, 126, and the original. So my negative 6 is already starting out there. It's waiting for another pair. So I have this pair of 2s, this pair of 3s, and a single 7. So multiplying these together, this is going to give me negative 12 times 3, so negative 36 square root 7. And that's the exact same with the next two also. So that's pretty simple.